Welcome everyone and thank you for joining us. Please enter your questions for the presenters in the questions panel of your GoToWebinar control window. And at the end of the presentation, we will get to them in the order received. This session will be recorded and the slides will be available on our website shortly after the live event. Now, I'll pass it over to our presenters, Floyd Smith, Director of Content Marketing, and Charles Pretzer, Technical Architect at NGINX.
Welcome to our webinar. This is the MRA AMA Part 10, and that means the Microservices Reference Architecture, Ask Me Anything, Part 10. We've been doing these for about a year now. The title of today's webinar is Kubernetes and the Microservices Reference Architecture. Presenters today are my colleague, Charles Pretzer, Technical Architect here at NGINX. He was formerly an architecture consultant and an engineering lead at several startups. I'm Director of Content Marketing. I've been with some large and some small companies, and I've written some books about different aspects of technology. The agenda today has a lot going on because we're bringing a lot of pieces together, and I'll just let you scan through it because it's more than I'll be wanting to read at the moment. I'll start off by introducing NGINX, and then Charles will dive into the technical aspects, both setting things up and then delivering how all this works together. So introducing NGINX. NGINX is a company. NGINX is an open source project, which is used on millions of computers worldwide. And NGINX Plus is the commercial version of our open source software. The open source software was first released in 2003, and it solved the C10K problem, more than 10,000 simultaneous connections on a single computer. The commercial version, NGINX Plus, was released 10 years later in 2013, and that serves the purpose of supporting and reinvigorating the open source project along with the company built on top of both open source and Plus. We're VC backed by leading investors in enterprise software. We have offices all over the world, more than 1,500 commercial customers, and more than 200 employees. Of course, the number of commercial customers, and that's at a company level, is small compared to the number of open source users that we have, which is immense. More than half of the top 100,000 busiest websites use NGINX. And if you look at the link, you'll be getting the slides. You'll be getting the slides and the presentation a day or so after this broadcast. But the reason that we have more of the busier websites, if you check out the W3Tech's Web Technology Survey that's linked from the presentation that you'll get, we have more of the busier websites, which is kind of backwards because these people are busy, right? They don't go installing software willy-nilly, even if it's cool. Well, I'll tell you what NGINX does for people. We play two roles that have led to us being used in very widespread fashion. The first one, I'll start in the middle of the diagram where you see the 4 servers running NGINX Plus. That's NGINX Plus or NGINX open source running as a web server. And that's the one that solves the C10K problem. So if your Apache server is having fits, can't handle the traffic running on it, you can put in NGINX as the web server instead. However, many people have quite tight coupling between their between the operating system, the web server, app server software, and the app that's running. So what do you do in those situations? Well, you put NGINX Plus in front of your stack as a reverse proxy. And over the years, we've added a lot of functionality to it. So it does caching, load balancing, SSL TLS termination, HTTP2 termination, security with a WAF, just a real long list of great functions. And what's cool is when you put NGINX Plus in front of your stack, you then shift a lot of the traffic management to the NGINX Plus server so that the existing server, whatever it's running, can simply handle the requests that are coming to it from the reverse proxy server. And that's much easier, makes everything calmer for the application server. And then you can use multiple application servers because the reverse proxy server also works as a load balancer. That then over time can replace things like ADCs, hardware load balancers. So that's a lot of the usage of NGINX Plus, is either to make an existing architecture better by replacing the web server, or by dropping NGINX Plus in front and using the reverse proxying and load balancing and other capabilities. And that means that busier websites need us more because they are the ones with traffic problems. So that's where we get adopted first. NGINX Plus works in all environments, so we're extremely popular in the cloud. We have one estimate that roughly a third of all the instances on Amazon Web Services are running NGINX, open source or plus. We work with containers, we work on bare metal, so very flexible. You can build a lot of intelligence into your web server or reverse proxy level architecture, and then that's less that the application needs to do. Makes it all more portable as well. And if you want to understand what our roadmap is for microservices, we have a number of presentations, demos, blog posts, which explain all of it. So if you're somewhat new to microservices, or if you know someone who is, who's wanting to get a sense for it, I would start out with the Intro to Microservices blog posts, which go through the major architectural questions about microservices. And then the microservice reference architecture shows different ways to solve those problems for more or less complex and robust implementations. And our sales team, believe it or not, is actually a great resource as you move along, because once you've had an initial conversation with them about your needs, there's a good chance that you'll get to talk to one of our SEs who's expert in this, and then you can engage NGINX Professional Services, which includes Charles, who's about to speak, who's an expert in helping you identify the right path forward for where you are right now that'll solve the problem with minimum of muss and fuss and maximum of scalability, resiliency, security, and all of those good things, as you'll see in the presentation coming up. And now let me turn it over to Charles. Oh, and please enter your questions for us to answer later. I'll be emceeing that part at the end.
Thanks, Floyd, and thank you everybody for joining us today. Good morning, good evening, good afternoon to wherever you are. I hope that you've joined us to get some good information about how to build microservices and how to understand the Ingress controller inside of Kubernetes. When I'm working with customers, we get a lot of questions from them about what is an Ingress controller, how do I use it, and we've come up with some good content here that I think will be helpful to understand some of the complexities around the Ingress controller, and hopefully to simplify it a bit for you. So what we're going to do is we'll start off with some basic concepts. You're probably already familiar with some of the things that we're going to talk about over the next few minutes. And as we go further into the conversation, we'll begin to dive more deeply into each of the configurations for the Ingress resource and the Ingress controller. We'll talk about the difference between an Ingress resource and an Ingress controller. And we'll also talk about some of the really interesting stuff that we're doing in terms of just kind of the future, a glimpse into our roadmap for microservices. And that'll all be prefaced by some of the information about where we've come over the last couple of years as we've been thinking about microservices. So to begin, let's talk about monoliths and microservices. Over the last 20, 25, 30 years, we've been building applications in a monolithic way. My career before I joined NGINX was to build large-scale J2EE e-commerce applications, which look a lot like this diagram that you see in front of you or on the screen now. The basic idea is that this large monolithic application is a single code base that encompasses it could be hundreds of thousands, if not millions of lines of code if one were to include the lines of code that are bundled with dependencies. And as a result of this, the customers that I worked with saw that as they wanted to deploy new features and fix bugs, they had to be very thorough about the testing that they're doing. And as a result, this slowed down their deployment processes to a point where they may have only been deploying once a month or once a quarter. And as you can see, this can be pretty detrimental if you're in our fast-paced environment where there's high competition to get a lot of features out or to have a product that's continuously evolving and growing. So the next logical step came around because is microservices and a microservices architecture. And this came around because in recent years, there have been some really nice advances in technology, much of which are based around just how inexpensive it has become to create virtualized resources, as well as how inexpensive storage has become. So as we move forward, as our migration from a monolith to microservices takes place, a lot of the questions that we get from our customers often ask me, well, what is a microservice, or how big should my microservices be? And so I've just taken a pretty simple definition from Wikipedia here. We at NGINX have also adapted, and you can see this in one of our blog posts, we've adapted the 12-factor application to building microservices. And so as part of that, we define microservices as a loosely coupled piece of business logic that works, although it provides standalone functionality, although it will not provide full application standalone functionality, meaning that it is a component in a much larger application. We like to keep these as small as possible and store them in a single repository. So when we're talking about an application built on a microservices architecture, we're actually talking about several different source control repositories, each that are independently, usually containerized, built into a single image or into a virtual machine, which is less common these days, but certainly some of the patterns that we saw. And so we saw what ends up happening is we can build and deploy each of these services differently. So there's the concept of a microservice, and then there's the concept of a microservices architecture, which we see in this slide here. So this microservices architecture is, for obvious reasons, comprised of several different microservices. And at NGINX, we've been thinking about microservices for quite a while. And this is largely based on the means of communication that each of these services are now using. In our monolithic application, we saw that microservices communicated in memory through remote procedure calls. So the communication was very fast, it was very secure. The downside to it is that, again, these features, this application had to be deployed in one big go. And so while the communication remained very fast and secure, there are issues around being able to be more nimble, and certainly customers that I have worked with have always wanted to be more agile as well. So when we look at this microservices architecture, when we sat down here at NGINX and looked at the microservices architecture, we saw that these single pieces of logic were communicating by providing endpoints to other services and making requests to other services as well. And so it was, for us, a bit of a no-brainer. Well, it was a big no-brainer that NGINX would fit very well into this architecture by being the network glue between, or the plumbing, if you will, between each of the services inside of a microservices architecture. And so as we started thinking through this, we began to discover, well, we didn't discover, we knew that there were features inside of NGINX that were readily available to help build these microservice architectures. So we'll dive into a few of those in the upcoming slides. The first of those is service discovery. So NGINX uses DNS for service discovery. Service discovery is important because as new services are added to the architecture, or as instances of services are added to the architecture, the services need to know about each other, or need to, when I say know about each other, they need to know exactly where the address and port where those services are listening. And so in a simple architecture where you have just a few services like the one we see here, we can already see that there are quite a few calls that are made in order to allow your load balancer or your traffic manager to route requests to each of the services, and even for the services themselves to communicate with each other. In this diagram, we see that each of the services, A, B, C, and the remainders, all communicate with a DNS server, and NGINX then communicates with that DNS server in order to send requests to each of those services. When the services communicate with the DNS server, they provide the location of their server IP address and the port. And then NGINX uses that information to send requests to each of those instances, or to each of those services. As we dive into Kubernetes specifically during this conversation, we will see that kubedns is an out-of-the-box solution with Kubernetes that allows us to facilitate this communication and provide the service discovery. So service discovery is just the first part, but let's take a look at the configuration of NGINX when we do service discovery. So this is a chunk of an NGINX configuration file. If you've ever configured NGINX before, you know that it's all usually text-based. It's pretty. It can be a bit daunting at first, but once you get the hang of it, it's pretty straightforward. So here we see there are four important directives here, and they're listed in reverse order. So the resolver is a directive that specifies the location of a DNS server, like the one that we saw in the previous slide. And this valid parameter tells NGINX that the DNS entries are valid for 10 seconds. This is configurable, and you can change this to whatever you need it to be so that you don't end up spamming your DNS server. One thing that we found with customers who have a lot of microservices, especially when they're spinning these services up and down very quickly through either auto scaling or some other form of orchestration, we find that sometimes it's better to have a shorter time. And this is something that there's no formula for this. I wish I could say that there was, if you have X number of services and they are coming online at such a frequency, then you set this parameter to a specific value. Unfortunately, we don't have anything like that. This is something where the services, we have to take a look at the performance of the application and then understand how to configure that timeout for the DNS. So the resolver is the first of the directives that I mentioned. Going down, we see that we have an upstream directive, and that upstream's name is backends. So hold on to that for a second, and we're going to jump down to the bottom. Inside of the server directive, we have a location directive, and the location directive simply says anything that comes in at the root, we're going to proxy pass it to HTTP backends, and that's where our upstream comes back into play. That backends, the proxy pass directive specifically configures NGINX to look for an upstream with this specific name. And in this configuration snippet, we see that NGINX will look for an upstream named backends, which we've defined. And then we see that there's also a server directive inside of the upstream block. Now, the server directive is specific to NGINX Plus because in NGINX Plus, we can use the DNS server to look up the serve records, which will give us, which will allow us to specify a server name, as well as the service and the protocol that it's listening on. And NGINX will resolve all of those service records. We've got a great blog post on this that has a really good illustration of what happens when the DNS server returns 3 entries for a service named backends.example.com. In that case, we see that there are 3 rows and they each have their own name, their own address, and their own IP, or sorry, their own port. And so the resolver takes each one of those, and then NGINX will know that it has 3 instances of a specific service that it can begin to load balance to. Which brings us to the next important piece of a microservices architecture, which is load balancing. So in our simple architecture, where we had just, or not architecture, but in our simple application, I should say, where we just had 1 instance of each of our services, we saw that NGINX would be able to send those requests to each of the services. But that's not really a true real-world application. In a real-world application, we see that there are anywhere from tens to hundreds of instances of a single microservice. And in that case, our NGINX instance needs to be able to load balance to each of those in such a way as to ensure that the application is performant and to evenly distribute the traffic across each of the instances of the service. And so here I've set up a diagram, a simple instance of NGINX Plus, which is configured to load balance to instances of different services. So on the left-hand side, well, let's start on the right-hand side. On the right-hand side, I've got services A and B, which are relevant for this diagram. And they are color-coded in such a way as to show that in our NGINX configuration, we've got a location that is /service A. And that matches that darker yellow color, which is our service A instance. And in that location block, we see that we're proxy passing to service -A, which is our upstream that matches in that lighter yellow color. And just like we had in our previous slide, we saw that the NGINX Plus instance is doing DNS service resolution so that we can load balance. In this case, we've got 2 instances of A and 2 instances of B. And so NGINX Plus is going to get those records back from the DNS server and be able to load balance across those 2. So in addition to just having load balancing in general, another really important topic I mentioned before is that we want to keep our application performant and running well. And so there was a time where round robin load balancing was sufficient for most applications. Now in a microservices architecture, we see that actually in any application architecture, but really in a microservices architecture, we see that having granular control over the load balancing algorithms to each of the services will really allow us to optimize the resources that are available to each of our instances of our service. So in this case, I don't have any specific load balancing algorithms configured. They're not in the blocks, and in the upstream blocks is where we would normally put them. I didn't do that because I ran out of space. I could have used a smaller font, but that only just occurred to me now. So that being said, the load balancing algorithms that this particular configuration will use is round robin, which is the default for NGINX. But with NGINX Plus, we've got a couple of different load balancing algorithms that are available to us. The most popular in a microservices architecture and in monolithic architectures, I would say as well, is the least time algorithm. And the least time algorithm takes a look at the response time from each instance of the service and simply chooses the instance of the service, which has the lowest current response time, and continues to load balance in that manner by constantly updating and monitoring those response times. There is a least connections algorithm where NGINX keeps track of the connections that each instance of a service has, and the instance that it has the fewest connections will receive the next connection. There are also a couple of more advanced or more complex algorithms like hashing and IP hashing. And so we've got some good description on those in our blog posts and in the documentation. But when I'm working with customers on microservices, I'm finding that they're leaning very heavily toward probably 95% of them are using the least time algorithm wherever possible and finding great results with it. So far we've talked about service discovery and load balancing. Another aspect of a microservices architecture is security. And so here we see that there's an instance of NGINX Plus that also has our web application firewall that handles the traffic that is coming externally and routes it to our DMZ or behind our firewall. And in this case, this is one aspect of security that we cover. But for us, when I'm designing our architectures for customers, or when I'm designing an application or a system with customers, some of the security that they're more concerned about is the inter-process communication between the services themselves. And so we have some customers who are simply required by regulation to have TLS communication behind the firewall between their systems or their microservices in this case. And other customers are doing this by choice. And so, or by business requirements, I should say, not necessarily by choice. And so I'll be diving into one of our architectures, which focuses specifically on secure communication between each of the between the services in a microservices architecture. So we'll be looking at that shortly. In addition to security, load balancing, and service discovery, monitoring has been a topic, or has been very important for applications as back as far as I can remember, just in order to make sure that our applications are healthy and are running. A new aspect, something that has popped up as I've listened to podcasts and read blogs and had conversations with folks specifically at DockerCon recently, is observability. And so there's a big distinction being made in the industry between monitoring and observability, and rightfully so. Monitoring allows us to ensure that our application is healthy, that there are no systemic problems, that we identify bottlenecks, and so on. Observability really gives us that fine-grained detail of understanding what happens in the lifetime of a request, from the time that it's sent from the customer or to the user or whatever client, maybe it's a mobile client or some other application, and that being able to trace that request through and understand how it interacts with each service, which services it interacts with, and to make sure that we don't have something like a circular call between our services, which can be pretty detrimental to performance of the system. So in this case, a recent version of NGINX Plus, we released a variable called request ID, which allows us to uniquely identify a request as it passes through the services. Now, there's some configuration work that has to be done in order to monitor this request or as it goes through the services, but it's straightforward, and I believe we've got a blog post written by one of our technical engineers here at NGINX. So those are the basics concepts that I wanted to go over before we really start diving into some of the meaty parts of microservices applications, and specifically our microservices reference architecture. So the microservices reference architecture is an application that we started building. Our chief architect, Chris Stetson, started building it nearly 2 years ago, I believe, and I had the opportunity to pick up and come in and work on it along with some other great members of our team. And this is a microservices architecture application that it's a simple photo sharing site. It's kind of like Flickr, uploading photos and being really, it's a simple application that has multiple features, the goal of which is to showcase using NGINX as part of your microservices architecture. So we have released all of this this application as open source. You can find it at the link there, github.com/nginx/MRA-ingenious. The application itself is called NGINX. It's a little bit of a play on words when it comes to NGINX and some of the fun things we like to do around here. One thing that we're going to see here is, especially as we start talking about the Ingress controller, is that this application was designed with the single point of entry. In fact, the application itself and some of the architectures that I'm going to show you predate the popularity of Kubernetes. And in fact, we designed these architectures to be orchestration software agnostic, which will allow you to use NGINX in your architecture regardless of which orchestration software you'll be using. So let's take a quick dive into the application itself. It's pretty fun to work with. In fact, let's first look at this diagram here. We see that there are 7 distinct services written in separate languages. I think we've got 5 different languages. Some of them have data stores, some of them do not. Some of them are simply for processing. So I'm going to jump over to this tab over here, and we can see that I have several deployments, which are the applications, the services themselves. Now at the moment, this is just a small cluster, so you'll see that I only have one of each of the pods running. In fact, let me increase the size on this. I realized that I often do this. There we go. So at the moment, I have just one of each of the pods running because, again, this is a small cluster. And we see that we have our auth proxy service, which is the entry point, as I mentioned. Our pages service provides the user interface. There we have an album manager, which keeps track of photo albums. Our user manager, which keeps track of user information, encrypts passwords and whatnot. So just as a side note, we do have some very weak encryption in our application. I don't recommend using this in production, and there are notes in the READMEs as well. So this is meant to be a demonstration application. Our goal is that you would download it, clone it, build it, and if you find, in order to really understand how to use NGINX in your microservices architecture, you'd rip out the code and put in your own services there. And so really we meant this to be as a blueprint for you to build your microservices. And in our professional services group, we often use this as a bit of a blueprint for building application architectures for customers. So here we see we have some persistent volumes. If you're familiar, if you've done any work with Kubernetes, you'll know that that is how one can store data inside of Kubernetes. And when the ephemeral portion of the application goes away, like this MySQL instance, the data itself still remains available through our configuration. So again, here we see the deployments. We've got all of our pods running through replica sets that are created when our deployments are created. And then we have our services as well. So Kubernetes has several different resources in order to properly represent each of the services. The services are defined with the endpoints and the locations to where other applications can get to the consent requests for the services. And then the deployments are actually the containers that are handling the logic. In this case, they're, like I said, they're pods. So let's just jump into what this application looks like and what it does. So here we see we have just a simple home page, an about page. Neither of those are gated. That was done intentionally. We have our off proxy service, which is the entry point, as I mentioned. If I try to go to my photos, I'm presented with the login page because I am not authenticated. So if I do just log in here, and so now I'm logged in, I've taken to my account page. I'm just going to add my name into my account, and from here I can begin to upload some images. So we'll just go, actually first, now we can go to my photos, and we'll see that here I'm at this My Albums page, and it is, there's nothing there. So we'll just add a new album. I got this dog one that I really like. And there we are. I can close this out and I can go back to my photos, which is just going to be this page. And now I have this album. And so what I hope you've seen here is that we've uploaded an image. The image has been resized. I only uploaded one size. We've also authenticated, created an account. And these are all provided to us by each of the services within the application themselves. So this again was the kind of the introduction to microservices for us. This is where like we decided we are going to build some architectures and we're going to build an application as a blueprint to help users of NGINX to understand those architectures. So with that, let's talk about Kubernetes for a bit, and then we're going to talk about the architecture. So Kubernetes and the NGINX Ingress controller, there's a lot to unpack here, just a few slides, but we'll go through it. So what is Kubernetes? This is my very simple diagram for Kubernetes cluster. It's an orchestration platform for managing containerized workloads. We can, it's a set of APIs that allows us to create containers and upload YAML files to the system, and this is the application or the cluster will pull those files, pull those images, create containers, and begin to run our application. So as we saw here, that's exactly what's happened. I've created several YAML files with definitions for each of our services, uploaded them to Kubernetes, and Kubernetes has then deployed them inside of pods. Something interesting that we've done, and this is part of the container, the architecture of this application from the beginning, is that we'll see in our fabric model that each of these containers, here, let me pull one of them up real quick, the YAML file for one of them. Each of these containers actually has NGINX running as a sidecar inside of the pod. So Kubernetes will allow you to run several containers inside of a pod. But in this case, our container has NGINX built inside of it as well. You can't actually see that from this YAML file here, but what I can tell you is that our Docker file contains the installation for NGINX as well as the logic for the service itself. Okay, so one of the main benefits for Kubernetes is being able to optimize virtualized resources so that we are making sure that our services, if they are slowing down because there aren't enough instances of them, we can configure auto scaling inside of Kubernetes so that once we have another, we can spin up more instances of our service so that they can run faster. There are several variants of Kubernetes. I encourage you to check out all the certified Kubernetes distributions. And then we can begin to talk about the Ingress controller once we have an understanding of the Kubernetes cluster. So the Ingress controller is we need to break it out into two separate pieces. We've got our Ingress resource and our Ingress controller. What we'll see is that the Ingress controller is the logic that actually carries out the routing that takes place. The Ingress resource is the configuration for that logic. The main reason for an Ingress controller is to consolidate the definitions for the entry points into your microservices architecture. Not all services need to actually have an entry point. It's entirely possible that you only need to, in fact, the NGINX application is a good example of a single entry point application. The auth proxy, because it handles authentication on its own, is the only place where we want to allow traffic into our cluster. All of the other services are internal to the cluster only and can't be accessed from external resources. So let's see. Oops, that slide didn't jump up. Here's one of my favorite slides, is that we have a side-by-side configuration comparison between Kubernetes Ingress controller, the Ingress resource, and our an NGINX configuration file. So on the left-hand side, we see that both of them define a server or server name, a host, if you will. And then we also see that our location configuration, NGINX maps one-to-one with a path location where the path is routed to a service. In this case, we see that /weather is routed to weather service, /places is routed to map service. And this is a different example, this weather demo. So please, I apologize if I'm confusing anybody by talking about the MRA and then going over to this weather demo. But in this case, we see that we are using path-based routing to send requests to upstream instances and services. And this is why, actually, I can't confirm this, but I suspect that this is why the Kubernetes community, when they created their Ingress controller, created one using NGINX as well. So that's another thing to make sure that we get a lot of questions about. There's some confusion around the fact that there is a Kubernetes Ingress controller that was written by the Kubernetes community, and then there's the NGINX Inc. Ingress controller that you can find on GitHub as well. And so I believe we've just released version 1.2. It's got full GC support. Unfortunately, I won't get a chance to that's one of the latest features that we added into it. So like I said, it's pretty clear as to why by using path-based routing to route requests to what are essentially upstream servers, the Ingress controller is a powerful tool for consolidating that configuration and specifically doing dynamic service discovery and load balancing inside of the cluster itself. So let's quickly go through the microservice architectures. We have our proxy model, which again, these were all created probably about 2 years ago. And so the proxy model is a very simple architecture where we use NGINX Plus to load balance traffic to services. The services themselves are left to do their own service discovery and load balancing as they communicate with each other. So in this case, this is really the most useful when we're migrating from a monolith to microservices and beginning to break down that monolith into separate services. As that process continues and the monolith begins to be completely broken down, we get to the router mesh model. The router mesh provides us, as you can see, we've got 2 instances of NGINX Plus, one handling external traffic and one that routes traffic between the services. And this is actually very similar to the Ingress controller itself. What we see here now is that the services are no longer communicating directly with each other. They're communicating with this router mesh instance, which then routes traffic to each of the services. And this is powerful because using that DNS service discovery that I mentioned earlier, this NGINX Plus instance can discover services, discover new instances of services, and load balance traffic to each of those instances using, again, that DNS service discovery. And so this becomes a single point of configuration. This is a simple diagram, so normally we'd see this run in a highly available pair, so that if again, this is orchestration agnostic, but even inside of a Kubernetes cluster, you could run this configuration in a highly available pair. And that would be very similar to the NGINX auth proxy application or service that we saw. The next is the fabric model, and this is where I mentioned when I showed you the content service and I said that we have an instance of NGINX Plus running inside each of the containers. So what we see here, and this little zoomed in, piece here, is that the instance of NGINX Plus is now managing all the traffic between the services. The services themselves are only communicating with that sidecar over localhost, so there's no latency there. And by using this configuration, we get the same service discovery and load balancing and even active health checks that we have from the router mesh. But if you remember, we talked about security earlier. And so this configuration using a keep alive mechanism in NGINX Plus allows us to do manage persistent SSL connections. And so what that means is when one service communicates with another service through that NGINX sidecar proxy, the configuration will then use this keep alive mechanism so that as long as the connection is consistently being used, NGINX will keep it open so that it doesn't have to renegotiate the handshake, the TLS handshake, or the SSL handshake. So the most expensive part of any TLS communication is the handshake, which can take 7 to 10 steps, and that's the highest overhead. The only thing that has close overhead, or not even close, but the next highest overhead is the encryption and decryption between the traffic. So anecdotally, what we found that by reducing the number of handshakes between the services, we are able to have, we see a 70% performance improvement over the case where the services have to continuously renegotiate that handshake on every request. So this has become very powerful, especially again in those industries that I mentioned where either by regulation or requirement, the services must communicate behind the firewall over SSL. So you'll notice that I'm moving a bit quickly here, so I want to make sure we get times to answer questions. So when we take a look at these architectures, again, which were designed before the popularity of Kubernetes, as we look, I promised you that we would talk about our vision going forward. And this is a diagram that one of my colleagues came up with where we are building towards a full service mesh. Currently, what we have is the fabric model is a very strong mesh that includes data plane, the data plane. What it doesn't include is the control plane, and that's where we're looking in the future. So when we're talking about the migration path, we'll talk about using the proxy model, which is an Ingress controller, where it's akin to, sorry, the Ingress proxy is the implementation of the proxy model on Kubernetes, where an Ingress controller is routing the traffic to each of the services, and the services are left to communicate with each other. Then we get to the router mesh, which is, again, it's parallel as the router mesh model that I just discussed with you. And in this case, the Ingress controller routes the traffic to the router mesh, and which then facilitates communication between the services themselves. The next step is the service proxy, which is the same as the fabric model, or it's the implementation of the fabric model in Kubernetes. Here we see NGINX Plus running as an instance or as a sidecar in every container or in every pod alongside each of the service containers. And again, this gives us that service discovery, the load balancing, as well as the SSL communication among each of the services. And the next step that we see for the future is a full service mesh where we have a control plane in addition to our existing data plane. And that is currently ongoing in one of our projects, which I will get to in a moment. Actually, yeah, let's move forward to that. I'm just going to jump forward a few slides here to our engine mesh. So the engine mesh, where did that go? There we go. Engine mesh is an open source project that some of my colleagues here at NGINX are building. And we are implementing NGINX as the sidecar proxy inside of the control plane, or sorry, inside of the inside of Istio. And so in this case, we see that we're using the Istio control plane, but as the project has become more mature, we've pulled out Mixer and we're starting to look at other streaming services for or we're using a streaming module specifically to send traffic to Kafka, as well as an open tracing the Zipkin module, which allows us that monitoring and observability that I mentioned before. So this is really what we're looking forward to in the future as we begin to have conversations around a full service mesh provided by NGINX. So with that, I think, again, you'll all be getting a copy of these slides, so I apologize that I had to gloss over some stuff, but I think I want to give you all some time to ask questions.
All right, thank you very much, Charles. And as you can see, there's a lot of threads coming together here and a lot of really deep thinking about software and microservices architectures happening in several places. And NGINX really is at the center of it. That's why we've had 10 of these webinars over the last year just on architecture. And between that and our blog posts, it really does kind of form a graduate level couple of courses on some of these topics. So we're proud of that work, and it's ongoing. No one has the answer yet, but we certainly have some good things for you to work with and improve your applications. Just a few questions that I'll cover off fairly quickly with Charles's taking the main load. First of all, does this all sit on top of Kubernetes or Mesos? And I can do an initial answer to that. It was originally designed, as Charles said, to be container orchestration tool independent. So it would work on top of Kubernetes, or it could work, it's not really on top of, it's intermeshed with, interacting with Kubernetes or Mesosphere, DCOS, or Docker Swarm. And what's happened during the time we've been doing this work is that Kubernetes is more often quoted and used. The other two contenders in the space are also supporting Kubernetes. So we can now mostly present Kubernetes first, and then if you're using one of the other tools, we'll difference off of that and say, okay, so for Mesosphere DCOS, this is different. Does that sound roughly right, Charles?
Yeah, that's exactly right. And in fact, if you go to the MRA NGINX repository, you'll see that we have files there for deploying on DCOS and building the images for DCOS. We started initially with spending equal effort, or planning to spend equal effort on DCOS, Docker Swarm, as well as Kubernetes. And to your point, as we saw that trend shift and as we saw those companies supporting these other orchestration or supporting Kubernetes, we also focused our attention on that.
So then a quick comment here from one of our questioners. Once the SSL TLS tunnel is established, services can communicate using the existing tunnels. Exactly, that is exactly what the point of it is. And we've done a little bit of measurement. And in one case, we had just a few percentages of the messages that were sent needed to open a new connection. The vast majority occurred over existing connections. Of course, part of that goes to your application design, which is the challenge in microservices. I will go on to another question, which is, what is our NGINX Plus management and orchestration solution in terms of load balancing, availability, et cetera? That's just it. We work with an existing orchestration solution. Today, talking about the more popular one, which is Kubernetes. And we have a partnership with that in actual operation. Anything to take that answer deeper, Charles?
Nope, that covers it. There's nothing I can really add to that.
Okay, so here's a question that I've been wondering about for a while. So we'll put Charles on the spot again. Why is a Redis cache required in the microservices reference architecture? The caching feature is provided by NGINX, so why is it not sufficient for this use case? So why you got two caches there, Charles?
Yeah, that's a good question. That cache is used for storing, well, it was actually just used to showcase how you could use a data store that isn't necessarily a file data store. You can use an in-memory data store. So again, we wanted to make the application as utilitarian as possible, and so or as real world as possible, I should say. And so that's why we included it there.
And that brings up a broader point. You know, if you're using a bunch of Redis caches and then you're going to implement a microservices reference architecture, you're not going to rip them all out to do it by the pretty diagram that we have on a PowerPoint slide. You're going to use the resources you already have in combination with new work. If you're already, this is what we hear from customers, if you're already a strong NGINX user, why stop doing that in order to go with someone else's PowerPoint slides, but combine what you have, you know, works well with new ideas and make it all work together. So that's what you're seeing here. This kind of, right now it's a rich soup rather than a polished solution. So sorry, why do we need NGINX controller when Kubernetes has its own controller? Another interesting question, which I will bravely toss to Charles.
Yeah, that's a great question, and there's we get that question a lot. There's an issue. It's issue number 190 on Kubernetes, where the author of the hopefully you can see this on my screen. It's the issue number 190 of NGINX Ingress, where the author of the Ingress controller gives the reasons for using NGINX Plus or the Ingress controller as opposed to the one developed by the Kubernetes community.
Okay, a quick question that I'll answer. Are there packages available where I have WordPress and NGINX Plus running in a container in the Fabric Mesh model? No, this whole area is so new that we haven't pulled together solutions like that. If you implement that yourself, the person who asked the question or anyone listening, we will cheerfully feature you in a blog post on our site, do a webinar with you, and have you speak at our user conference, because that would be quite a popular solution. And it would take a lot of work, because right now people are given you tools and parts, even as we are here. Although we have a complete architecture, there's a lot of work to do on the implementation side still. So no, that isn't all packaged up together yet, I'm pretty confident in saying. And then is NGINX, this is the last question we have time for. I'm so sorry, there's a couple more. Stay on, if you've asked a question, stay on and I'll at least give a brief answer, or even I don't know if I have to the existing questions, but you'll know what we know about them. But the last question we're going to handle live. NGINX Plus is redundant in all the MRA models. No, there are a couple of NGINX Plus features that get used rather heavily. I'm just going to choose one. Well, no, I'm going to choose two. One is the advanced load balancing algorithms, which are in NGINX Plus and not in NGINX open source. And the other is health checks, really important for things like the circuit breaker pattern. We have an entire recorded webinar about using the circuit breaker pattern with the microservices reference architecture. So I'm kind of excited that we're getting to this level of coverage on some of these specific questions. But no, NGINX Plus also having support. When you're on a project like this, you've got a couple dozen people working together, and you've got tens and hundreds of thousands of customers doing transactions on your site. Support's a great element of that, and we support the NGINX Plus solution. So I'm going to finish off these questions offline, and I will say thank you from both Charles and I very much for your attendance today. This was a very popular webinar in our series, and we really appreciate your guys' engagement on this journey with us. Thanks again. Bye-bye.
Bye, everybody.